Hello everyone, we are Mohammed, Basma, Sisi, and Qixin from the Ningbo China Institute for Supply Chain Innovation. Our research topic is Fixing Carbon Black Spots, how digitalization enables emission reduction. We know that many firms have climate targets, but they cannot clearly see where their emissions come from. They usually have good control over Scope 1 and Scope 2 emissions from their own production, but most emissions come from Scope 3 activities across the supply chain, and those are much harder to see and to manage. This creates what we call carbon blind spots, and that's why digitalization matters. It helps companies see more clearly and turn data into real emissions reduction actions.
Therefore, the problem is that limited emission visibility makes high-impact sources hard to detect, which prevents companies from designing effective and targeted decarbonization strategies.
This proposal uses a survey-based structural equation modeling approach to study how digitalization supports emission reduction outcomes. We will design the Likert scale surveyed items to mention four key constructs: digital enablers, emission visibility, decision-making precision, and emission reduction effectiveness, and collected data from managers in supply chain, sustainability, operations, and digital roles. The structural model will be tested to examine how digital enablers influence emission reduction effectiveness through emission visibility and decision-making precision. Reliability and validity will be assessed using Chromebus Alpha and average variance extracted, and bootstrapping will be applied to evaluate mediation effects.
Okay, so now let's see the expected result. Based on our hypothesis PLSSEM model, we expected firms to differ in how digital enablers translate into emission visibility and ultimately emission reduction effectiveness. We therefore anticipate four broad classes of companies, depending on whether digital enablers and emission visibility are high or low. In particular, firms that combine high digital capabilities with high emission visibilities are expected to achieve the most effective emission reductions, which we refer to as digital decarbonizers. These classes will be analyzed in further details to uncover systematic patterns in decision-making precision and emission reduction effectiveness.
Now, concerning our expected contribution, is to create a framework showing how digital tools improve emission visibility and help firms turn carbon data into more precise and effective emission reduction actions. Thank you for your listening.